machines would be a much better solution, because no dilution refrigerator, room temperature, put it in a service room, your IT people can bring it up online. We know that based on the installations that we've done for some of our clients. Just recently, we shipped it somewhere, and the time that it took from it getting out of the crate to being running in their server room was less than an hour.
While we're waiting for fault-tolerant quantum computers, is it possible to achieve advantage in real business problems today? Application-specific photonic systems are showing a lot of promise, as showcased by a recent experiment in financial fraud detection. Find out how these rack-mountable, room-temperature quantum computers work in this episode of the Post-Quantum World. I'm your host, Konstantinos Karagiannis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Our guest today is the Chief Revenue Officer of Quantum Computing Inc., Pouya Dianat. Welcome to the show.
Thank you so much. Pleasure to be here.
Yeah, great to have you. I know as we're recording, there's a lot going on for your company, so we're going to dive into a bunch of that. But for those who don't know, maybe didn't hear the episode years ago when you had a colleague on, tell our listeners about QCI.
Yes, QCI, Quantum Computing Inc. It's a publicly traded NASDAQ-listed quantum technology company. It was established in 2018 as a quantum software company, but the leaders in the company very early on realized that in this quantum race, you need to have the full stack. So over time, multiple acquisitions happened, and the quantum hardware technology based on photonics, nonlinear photonics, got added to the mix and became a full stack. And we do work in the quantum industry, basically, and basically target three main things: capture, compute, and communicate. Or basically the marketing names for quantum communication, computation, and sensing. So we do offer products and some services in this area. All of these are based on the core technology that we have. It's based on nonlinear photonics. That's been the core part of our team have been doing research on it for the past decade, more than a decade or so, and that has become the foundation of our quantum technology in various aspects. So one way or the other, in any of the capture, compute, communicate that I mentioned, we are leveraging the nonlinear photonics, and particularly based on this exotic material called thin film lithium niobate, which is the enabler of us being able to make the nonlinear photonics happen and harvest the quantum aspects of light through that.
So because people don't hear about that type of photonics too often, just real lightly, if we could touch, how does that generally work? Does it lead to full gate-based quantum computing?
It will eventually lead to full gate-based quantum computing, although what we are currently focused on and doing and offering is an analog quantum optimization machine on the computing side. So that part is an analog machine. So it's not gate-based. It's not like a universal quantum computer. It is application-specific quantum optimization machine. So that's and there are good business reasons of why we are doing it that way, as opposed to just a cool research that goes behind it. So that's there is this approach actually covers the business case and the business model of the company, addresses that, as well as the long-term plans of getting into gate-based quantum computing.
Okay, yeah. So I was trying to capture the essence of who you guys are from episodes past. So you guys recently did a $73 million acquisition. And how does that help your whole semiconductor kind of approach that you're hoping for?
Yeah, so I think it's a known fact that the quantum is a very hard technology. Otherwise we weren't doing it. You can say it's more complex and complicated than rocket science, and it is indeed. So there is a lot of technologies that we need to have and cover to be able to get to be able to realize a roadmap that we have in place. One of them is basically the topic of the packaging and heterogeneous integration, to be able to put different materials on top of each other, different optical materials on top of each other, that you get a functionality from each of those, but you need to make sure that they are efficiently connected and coupled together to be able to harvest the quantum nature and preserve it. And that's actually what with the enhanced technology we get, and that is a critical part of our roadmap and the technology enabler. So it is in the service of our long-term quantum roadmap, as well as a short-term plans. So that is an enabler. And before that, actually, we did another round of M&As. We acquired Luminar Semiconductor. That part also gave us the critical technologies in light sensing and in detection, as well as in generating light, and also packaging capabilities. So all of these are part of the same story. So the technology for us to be able to deploy it in volume and make it repeatable and useful for everyone, we need to have these critical parts of the supply chain and in our control to be able to efficiently design our quantum technologies and quantum computers and deploy them with the manufacturing and large scale manufacturing in mind, because we don't want to go, we never wanted to go after inventing a technology that no one can manufacture, because then we have to go and try to source suppliers of that, and then that makes deployment of the quantum technology very hard. But with the approach that we are taking right now, we are making sure that the manufacturability is a critical part of our vision for deploying of our quantum computers. And it's not only something that research is done on it, and then at that point, once the research is complete, once the good results are get, we have to go and scramble, figure out how we can make it.
Yeah, to that point, you've like accelerated your manufacturing timeline basically, and our industry's reacting already to that. Are they saying, "Hey, help us with this kind of approach or this kind of problem"?
So it's very interesting, because the problem that we are trying to solve for our quantum computing is a problem that other industries that currently are trying to address as well. So what we solve for our quantum technology is dual use, and there would be other market segments, particularly as it goes for the data centers and AI infrastructure, and for basically for what the data needs that they have. They also need to address similar kind of problems. So what we solves our problem and likely solves other people's problems. So I'm sure there is no shortage of business that would come from like these sort of hard problems that we are trying to solve. But for us, it's the main focus is on the quantum computing part, and the ethos of our company and the vision that we have is putting quantums into the hands of people and regular people, and we are ambitious and we say 1 billion people. But what that means is that like these different aspects of the quantum technology that we have, the computer, communication, and sensing, we need to be able to make millions and billions of chips of them and deploy them, and then have them coexist with the current compute and communication infrastructure. And for that sort of vision that we have, we need to be able to have the manufacturing capability, and that's and look at it from the very beginning of the journey, not closer to the end. So that's why it motivates us to bring all of these different technologies into house, have the manufacturability in mind, as well as the businesses that we have acquired. They already have existing customers and market segments that they are addressing. So we are not losing on those opportunities, while at the same time we are controlling that to serve our own purpose.
Yeah, I mean, revenue's in your title, so I'm hearing that in your answers.
Yeah. That's our business. I mean, at the end of the day,
Yeah.
we have moved on from the state that like quantum is a cool science that is done at the lab, and then now you are scrambling around and trying to find we are not a solution in search of a problem. So we are past that stage. We are trying to, by listening to our customers, by the kind of problems that they have, trying to adopt our technology into the product that is useful to the enterprise customer, regular people, like normal people's and everyone's right now today. So that's part of the motivator of going after the analog quantum computers that we have, because it can solve problems today as opposed to, let's say, into 2030s. Because we are a publicly traded company, our shareholders have put a lot of trust in us, have provided a lot of capital to us, and we have to deliver and we have to show value to them. And we think that there is a pathway using our technology to do that in near term as opposed to in 2030s. That is typically the case for other modalities of quantum computing.
Yeah, and you've mentioned solving problems, and in a moment we're going to get to, I guess, the crux of this conversation, one of the most impressive ones recently. So, but before we do that, I just want to point out that Trump recently handed the quantum industry a sort of little present in the form of two
Sure.
executive orders, and
Yeah.
one of them is about accelerating, development of the entire industry, really, and one of them is about accelerating the timeline to migrating to post-quantum
Mhm.
cryptography. So you guys kind of touch on both sides in a way. I mean, communications, and then of course the computation. So how does this affect like the regulatory and sales landscape for you?
Every time that I see that this sort of support is coming from the government, it actually makes me very happy because uh, the quantum technology is being recognized for what it is and the power that comes with it and what it can do. In terms of the security, the PQC that you mentioned and adopting of it, it's something that is going to be very important for us. One of the key technologies that we have on the quantum communications is our quantum authentication. So basically, we add a physical layer to the typical QKD that people are aware of. We add an additional physical layer to that is quantum mechanically authenticated, and that's something that is unique to us. Because if you look at other QKD technologies that are there, and QKD is quantum key distribution, basically. So that's good, and that's secure to distribute the keys quantum mechanically. That's perfect. But before the keys are distributed, the authentication between the point A and point B, or Alice and Bob, is done classically. And then an intruder can come and break that authentication channel because it's classical. And then if it's not authenticated, how good is it that you are distributing the keys? We address that part of the problem with our technology, with our quantum physically unclonable function technology that we have, or quantum authentication technology and patent that we have, to make that authentication also make that authentication channel also physically quantum mechanically secure. So an intruder cannot come and break into the authentication before the keys are distributed. So that's our additional value and stack that is being deployed out there. And then you never, at least for sensitive data, the more security you have, the better. I can assume that for sensitive national data or information that are being transmitted, or for bank transactions or bank information or those sort of things, the more level of security that you have, the better. And that's the main business model for bank and financial institutions, to have it as secure as possible. And we think that we can contribute to that. So a push for more immediate adoption for that basically puts us on the spotlight, because now we are going to now people are going to ask us, okay, well, when is your solution ready? And to that front, we recently did a demonstration with Sienna, which is a network infrastructure company, that shows the coexistence and co-deployment of our product, the quantum authentication, along with their network structure. And we did it at Optical Fiber Conference in California this past March.
Yeah, and I guess the idea is when you're dealing with a quantum internet one day, or quantum networking in general, it's going to have to be a physics-based solution to protect it, because of the nature of protecting entanglement and all that sort of stuff. So I guess by focusing on that with your technology, you're in a good spot for that whole stack, really. So let's move on to what some listeners are probably waiting for here: application, right? Like what are we going to do with all this good stuff?
Yeah.
You hinted that there's a reason you didn't choose gate-based just yet,
Mhm.
and I want listeners to really understand what that's all about. So financial fraud detection.
Mhm.
Major use case. I mean, it comes out of my mouth literally every time I'm talking to someone about use cases. It's always like optimization, fraud detection, and then pick one other one. It's gonna be mentioned.
Yeah.
So it's an arms race. You've got like traditional methods being utilized. They struggle with training times, feature complexity, etc. So how does your new algorithm, which is called, I guess, CVQBoost, how does
That's
that
correct.
change how banks or financials would look at high dimensional transactional data?
Yes, it is actually CVQBoost uses a series of weak classifiers, and then
Mhm.
makes it into a strong classifier. Now, in a sense, this problem can be translated into an optimization problem. Because if you have a series of weak classifiers and you are trying to construct training based on that, you need to know the weights that you're assigning to each of these weak classifiers.
Mhm.
And then you can write them as a sum equation and try to minimize that function, basically. And that is natively an optimization problem, which you can directly map it into the physics of our system, the Hamiltonian of the system that we are trying to solve. So that's why our Dirac 3 system that we have, it's a continuous variable optimization that we have, and we can map this weak classifier or this classification problem into the Hamiltonian as an optimization problem, and then let the system evolve into the ground state energy, which is the or minimization of this problem. So and that is a way that you can clearly make one-on-one correspondence between what you are trying to achieve and the physics of the system that you are trying to solve, as well as, given that it's based on photonics, you can solve this problem really, really fast. And given that we are leveraging the physics of the quantum, the physics of quantum mechanics in here, and the way that the Dirac 3 system is designed, we can always ensure that we always fall into the global minima of the system and not just be trapped into the local minima. So the other advantage that we have is, given that it's photonics based, you can load a large amount of data into it and not be beleaguered by like the memory limitations, or not be beleaguered by the processing power that is needed, and any of those. So we end up getting into the photonic computation facilitated by quantum mechanics, that you can process large amount of data, solve this very complex math problem, particularly for something like the financial fraud data, which it's kind of like sparse data that you need to train the system based on that. And for classical approaches, that is something that makes it very complicated, because if the number of fraud data in a very large amount of financial fraud transaction data is small, then your training is not going to be as reliable, because the AI doesn't have enough instances to be able to be trained properly. That's not the case for us, because, like I said, even based on the small number of features, our machine can always fall into the global minimum, and then it avoids the problem that the classical approach has. So we can process large amount of data at minimal amount of power and be able to show better results compared to the classical ones. And yeah, go ahead.
No, I was going to say, have you done any of this kind of benchmarking also with, let's say, digital or quantum annealers too? To like see
we haven't done it with other digital or quantum annealers at this point. It's our competitors, I don't think they were all willing to open their computers to us to be
Why
able
not?
to use that. It's I mean, there are rumors that we hear around that for people that have used our machine compared to others' machines, and they give us very interesting testimonials, and they come and pat us on the back, and they are like, "You're doing a good job." So there are these sort of like rumors and data that we get from some of our users, but we haven't systematically benchmarked us versus against like someone else, like other quantum companies that are out there.
Yeah, I mean, in the space of optimization, this concept, I mean, D-Wave, for example, they've numerous times called it customer advantage. You know, like they run their machine and they find that it works for them, so it's like customer advantage. I mean, you know, who knows? It'd be interesting to see if someone has a lot of experience in Leap or whatever, how they feel that this compares.
And more and more users are going toward that direction. And to that front, it's a matter of having access to these machines and different modalities of computing. And more and more you can see that the end users are going after all different modalities and try to test and try every one of them and see which one serves them the best. And it's always good for us to see a customer or a client of ours tries our machine first, and we don't hear from them for some time, and then we ask them, okay, what's going on? Then they're like, oh, we are testing others. And then after another couple of months, we hear back from them, and they're like, okay, so what are the next steps? So that's always a good indication for us that we are doing something right.
So um, traditionally with fraud detection, in the toy problem, that's great. It's,
Mhm.
you're playing around, you're trying to figure out your use case for the future. But when it comes to production, a lot of times the issue is a bottleneck, access bottleneck, right? The idea with fraud detection is you don't want to find out that someone ran up a few grand on your credit card 6 months later. You want to be able to actually do it today.
True.
So how does your approach, because of, I mean, I suspect what the answer will be, but how does your approach get around this bottleneck?
So again, the main thing is we are leveraging photonics. So we are operating literally at the speed of light, and that enables us to do to process the data really fast and really quickly. In the benchmarking that we did against the GPUs and CPUs, we saw multiple, even up to an order of magnitude performance improvement in terms of time, the training time that happened. So you can imagine that gives an advantage to a financial institution because then they can complete the training more in real time as
Mm-hmm.
opposed to like depending on the training that was done yesterday. They can depend on the
Mm-hmm.
training that is continuously being updated and for new threats that are coming in, for new financial fraud instances and all of those. You want to be as up to date as possible with the new data that is coming through. So that using our system enables that. And the access, that's another thing that you mentioned, and that's an advantage for our quantum computer. It's a machine that operates at room temperature. It's a machine that is rack mountable. You can put it in a server room, and it's a machine that the infrastructure for running it is not that much, both in terms of like the capital equipment that you may need to add to someone, a customer may need to add to their operations, as well as the talent that they need to hire. So both of in those fronts, our machines would be a much better solution because no dilution refrigerator, room temperature, put it in a service room. Your IT people can bring it up online. We know that based on the installations that we've done for some of our clients. Just recently, we shipped it somewhere, and the time that it took from it getting out of the crate to being running in their server room was less than an hour. I don't think that you can tell that for many other quantum technologies. So
So
that sort of advantage it's the part that I think our machine has. Again, we are targeting the analog and application specific,
yes.
and that's why we think that this is a winner because we can do it today as opposed to like making people go through a lot of infrastructure investment and all of that before they can really leverage the machine.
I want you to send me the like insert, the quick start insert, step 1, 2, 3, like so I can like show it in the video version. Step one, 7 people lifting the thing out of the box. No. Yeah, but in all seriousness, so customers today could, in theory, try this in some kind of like cloud version and then buy one. Is that the idea?
There is, yes, they can access the cloud version. Our machine is available. We host our own cloud as well as it is available on some of our partner data centers, Quantum Corridor particularly. It's a, I think, Illinois or Indiana based quantum data center that is hosting our machine, and people can also access the machine through them and through us as well directly. And that's one way because then we understand that our clients want to get a flavor of what the quantum computer is before they invest on buying this machine. And for certain other customers, because of the sensitivity of the data, they want to have it on-prem, and we do understand that. And like I said, our machines is very easy to ship. We recently did a demo of that in Japan. This and also in the UK. This machine travels well. It's the same machine like flew to London, then from London went all the way to Tokyo, then from Tokyo it went back to Europe before it's coming back. It came back to the US, and the machine kept performing. So again, this is the sort of resiliency and the design of this machine that we
Yeah.
have. I don't
And
think.
having your own obviously eliminates bottlenecks. There's no
Right.
one else waiting.
Yeah.
There's no
Yeah.
queue. It's you. You're
That's
the queue.
that's true.
So no, that makes sense. And I understand the approach of having a series of weak classifiers and all that.
Right.
And it's been done in other versions over the
Mhm.
years and in quantum problems. So does that allow for an extra level of explainability then?
100%. I mean, it's unlike the traditional AI GPU base, that it's
Mhm.
kind of like a black box. You feed it in, and then you get the training out, and you never know what is happening in there. The hallucination happens, and that's one of the reasons that no one can understand what is going on. The AI hallucination. That doesn't happen in our case because, like I said, the physics of the device, the Hamiltonian, or which is the physical equation that governs our machine, it's one-to-one mappable into actual the industrial math problem that you're trying to solve. Whether it's a math problem for a bank, whether it's a math problem for a financial institution, for logistics, for all of those, you can make one-on-one-to-one correspondence, and then you have knobs that you can turn on the machine and be able to explain why you got the results the way that you got the results. So that has large implications because for financial institutions that are heavily regulated, or for insurance companies that are heavily regulated, you don't want to face the situation that you are accusing someone of committing fraud, and you are not explaining, you're not able to explain why it's happening, or why that has happened. And that's not the case for us, because you can go explain, and then you can always be like, okay, based on this physics, this is why this situation happened, and like why we are calling this a fraud. Now, that's something that I don't think necessarily exists in the GPU based AI calculations. That there you are like, okay, I said that it is the case because the AI told me. I don't know why AI told me that. That's
Mhm.
so that's some value that we have using our machine. But that all said, we have to also be cognizant of the fact that the quantum computers in general, that's inclusive of ours, it is not a deterministic machine. It's a stochastic machine. So it's based on statistics. So the results that you always get from the computation results, it is statistical. So we have to keep that in mind. That I always make this kind of true, give the like analogy that if you ask a quantum computer what is 2 multiplied by 2, it's not going to give you the answer 4. It's like 95% is 4, 5% is 15. That comes from the statistics part of it.
Mhm.
But that set aside, there is a way of explaining on how the physics look like in this machine, and why the statistics and this distribution looks like the way that it looks like. That has a lot of value for customers and for heavily regulated industries and all of them, to be able to point to what is going on and be able to defend their position.
And to tap into potential other use cases or a broad category of them, I know you recently had a framework agreement to have your system involved in next generation AI. I don't know if you can like explain a little bit about that and how you could see it impacting that whole field.
I believe you're referring to the Planck Dynamics framework agreement
Yep.
that we had. Yeah, Planck Dynamics is a Dutch company that is looking into using our Neurowave system, which is a photonic quantum computer. It is not a quantum. Sorry, it is a photonic computer. It is not a quantum computer. It
Mhm.
is a classical computer. It's AI at the edge, which can process large amount of data on the edge with fractional power, or with minimal power, because it's based on light, and light doesn't consume much power. So that gives tremendous capability to whoever wants to perform AI operations on at the edge, that doesn't have access to large amount of power and just has minimal power. Let's say battlefield situation. Let's say you want to have it on a drone. Let's say you want to have it go into a vehicle that you don't have like infinite amount of power, and you cannot afford to get connected to the cloud because of latency situations for the data transmission, or because you don't want to leave a footprint that you are actually transmitting data over cloud. So there are situations that you need a powerful AI at the edge with minimal power, and that's what Neurowave is. It's a photonic AI machine that Planck Dynamic is going to work on these machines to deploy it for the applications that they are looking for. It's multiple fields that they are looking for, including defense.
And are you guys going to participate in any other layers of quantum for AI or AI for quantum, either way? either direction?
Interesting enough, I think the quantum and let's say quantum and classical and AI being part of the classical are very complementary to each other. So the quantum cannot necessarily, in certain areas, it may outperform the classical computer, but it is not in every area. So it's
Mhm.
not a replacement for it, but it's a complement to that. And we are currently right now working on certain use cases that that our quantum computer can actually help GPU clusters and for them to work side by side together for better, more efficient performance at the end of the day. So these machines, the GPU and the QPU for quantum processing unit, are going to work side by side in our vision in coming future, side by side for together providing a better compute infrastructure for people. So yes, we do see that that all both are going to work together for better performance.
Okay. And for a while, this whole industry has been very much like heavy on research, light on revenue. So, as a CRO, publicly traded quantum
Right.
company, what's your philosophy on balancing like long-term quantum R&D with delivering something now, to shareholders?
Yes. So the main so the quantum industry is very new, so we have to create the market for it. So that's us, and that creating the market means that we have to focus on adoption, and we have to show find the use cases and applications that are useful for people today, and that's where we are focusing on. And as a CRO, my focus is on generating the revenue for the company, but you cannot generate revenue based on the non-existent product. So and the product needs to be defined, and that's the part that is we are also focusing, and that's the market adoption part that I was talking about. We go after the applications, work very closely with our customers to first show them that there is that the quantum technology works. The first thing people are asking, okay, quantum technology, it's a technology of the future. It's not today. And then our focus is to first show that no, there are applications that they can benefit from it today. Some colleagues of ours at Singapore Management University actually have used our machine for portfolio optimization, for financial portfolio optimization, and they are showing advantages that is today. So the first thing is to first show that the quantum is actually working today, the advantage is today, and how the companies can benefit from it today. So that's the adoption phase that we are going through, and we can monetize that. That's something that in the short run, once we have the interested customers, it gives them competitive advantage to have access to our quantum technology, and therefore they are willing to pay for it. So we are after monetization of that part, while in parallel we have our research and we have our R&D roadmap for more advanced computers and next generations that are coming through, while we are pushing that through. So again, there are easy ways, or not easy ways. There are ways to monetize the advantage that we have today, as well as being able to push our technology roadmap. That all said, we have, like I said earlier, our technologies, some of our manufacturing technologies that we have, they do have value for other market segments. It's not on the quantum, but for other market segments, for instance, that we can leverage those to generate revenue, and as well in the short run. So there are pathways for us to be able to generate revenue and show value today while we continue our R&D roadmap.
Okay. And speaking of today and this year, so before I let you go, looking out at the remainder of the year, we have these new federal deadlines appearing. So what does a successful year look like for you guys? What kind of milestones should the industry be watching for too?
For us, at the end of the day, QCI is a business, and it's a for-profit business, and we'd like to, with a vision of bringing quantum into the hands of a billion. But that starts from the very first steps, and the successful year for us is to demonstrate the adoption of various technologies that we have, as we have done so far, and as we have stuff in our pipeline that we are hoping to convert them this year. So the success for us is to show that, we are taking the first steps, the concrete first steps toward putting the quantum into the hands of the people. And I would be popping a champagne at the end of the year if or when we announce how our technologies on the computing, on the communication, and on the sensing side are being adopted by actually commercial an enterprise entities, and not necessarily just as an R&D sale, but for real commercial applications.
Yeah, sounds good. Thanks so much for joining, Pouya.
Thank you so much. It was a pleasure being here.
That does it for this episode. Thanks to Pouya Dianat for joining to discuss QCI. And thank you for listening. If you enjoyed the show, please subscribe to Protivity's The Post-Quantum World and maybe leave a review to help others find us. Be sure to follow me on all socials at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Protivity. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out Protivity.com or follow Protivity Tech on X and LinkedIn. Until next time, be kind and stay quantum curious.